Basically, yesterday we have started with the basic introduction to the digital signal processing. Now, in digital signal processing, when we are dealing with the signals and the systems, and basically we have started with some the important characteristics of the systems. Not about the signal, I am talking about the system. Okay, now these important characteristics we have said the linearity, causality, and the time invariance. Okay, because later on we will be dealing with the linear time invariant systems. Therefore, these properties are very important. Now, we have yesterday started with the linear system, how to define the linearity, how to find out the linear whether the system is linear or not. Okay, so this thing we have yesterday started with. Now, again, we will go through some the linearity property of the system. Now, basically, by looking at the equation itself, the system equation, you can tell whether the system is linear or not. Okay. Now, the thumb rule to check whether the system is linear or not. So there are some operations. By looking at the expression of the output, we can say that whether the system is linear or not. So how to find the system's property? So you can check for the following operations in the system expression. Okay, so the we can say these are the thumb rules to check the linearity of the systems. So what are these rules are? So these are the rules you can check in the output expression. One is the scaling of the input signal. Okay, so how to scale the input signal? So to scale the input signal, we can multiply that particular signal with some scaling factor. So here in this case, this A is nothing but the scaling factor. Okay, so this x of t is the input to the system, y of t is basically the output of the system. So this total is nothing but the output expression of the system. Okay, now this operation you can check. Then second operation is time shifting in the input signal. Okay, so if there is a time shifting in the input signal, so how to represent time shifting? So this we can represent like this. So we are having x of t as an input signal, but time shifted input signal is nothing but represented as x of t minus a. This is time shifted input signal shifted by a. Okay. Now scaling the argument of the signal. Okay. Here is also a scaling. This is also a scaling. Now this is the scaling of input signal. Now this is the scaling the argument of the signal. So we are basically, this is represented as x of at. This argument of the signal means this is this scaling factor a is multiplied with the independent variable t. Okay, this you have to remember the difference in this two. Then combination of any three above. Combination of any three above, if it is there in the system output expression, so we can say that this system is linear system like this. Now for this example, now here the expression is, you can see this is 2x of 3t minus 4. So this 2x of t is nothing but the first operation, that is scaling of the input signal. Then this t minus 4 is nothing but the time shift in the input signal. And this multiplied by 3 is nothing but the scaling in the argument of the signal. Okay, all these three, the combination of these three is here. Okay, so you will find many combination of these three operations. So if these combinations are there in the system output expression, then you can say that this particular system is linear system. Otherwise, the system is non-linear. If system is not linear, then system is non-linear. We say it as a non-linear. Again, summation of the term that are linear, if there is a summation of linear terms. Linear terms means you will find the combination of about three expression. Summation of this combination of this three expression is also, you can say that the system is linear. Okay. So now what are the particular non-linear operation? If this type of operation you will not find, then you will find some different operations. So the particular non-linear operations you will find like this: the multiplication of the signal. Okay, if you find the signals which is multiplied by this, so you can say that this is multiplication of input signal. So this is nothing but x square t. If you will find the system expression like this, then you can say directly this particular system is non-linear. Then if there are any nonlinear functions applied on the signal, so nonlinear functions like sine, cosine, so these type of function if you find in the output expression, then also you can say this system is nonlinear. And addition of this thing, again, if you add some constant term in with the input signal, then also you can say that this system is nonlinear. Adding of constant term is also a system nonlinear because this is independent of the signal. The addition of this constant a, which is independent of the signal, therefore this system is nonlinear. If it is x of t plus a into x of t, if it is like this, then this system is basically a linear system. You can say it is linear system. Okay. So these are the some thumb rule to check whether the system is linear or not. Okay, by looking at the equation, you can tell it. Then we will see some examples in this tutorial session to check the linearity of the system. The next characteristics is basically the causality. How to check whether the system is causal or not. Okay. Now, why this causality is very important? Now, the property of this causality is requirement for a system to be realizable in reality. Therefore, it is very important. Now, what this causality means? So, this causality means that the output of the system does not depend on the future input, because in real system we cannot find out the future uh, inputs. Okay, the output from the future input. So this is not realizable in reality. Therefore, we need to check whether the system is realizable in reality or not. So to check for that, we need to check the causality of the system. Okay. So causality means what? The output of the system should does not depends on the future input. Okay. So it may depends on the present and the past input. Okay. Past input and present also. So how to check whether the system is causal or not? Now, for example, if you take this system 1, which is represented as y of t is equal to x of t minus 1. Now, to find y of 0, I will require x of minus 1. Now, this x of minus 1 is nothing but what? Past input of the system. Therefore, this system is causal system. Okay, this is very simple example. Now, if you take system 2, this is what y of t is equal to x of t plus 1. Now, to find y of 0, in this case, I will need x of 1, which is what? This is future input of the system. To find output at t is equal to 0, I will need input at t is equal to 1, which is not realizable. Okay. Therefore, this system is non-causal system. Okay. Because nobody can look into the future. It is impossible to realize. Okay. Now, again, we can also plot these waveforms, simple waveform in this graph. In this graph also you can see this is input x of t. This is the step signal. X of t minus 1 is what? This is delayed by 1 second. So this is the expression. This is the plot for x of t minus 1. Now input is what in this case? This is blue line is the input x of t. X of t plus 1 is what? At t is equal to minus 1, this input will start, which is not, the output is at t is equal to minus 1, which is not realizable. Okay, so by looking at the graph also, you can say that the system is not realizable or realizable. Okay, so this is the second property of this system, second characteristics of the system. Okay. Now, the third important characteristics is the time invariance. Now, time invariance, how to define time invariance? Before yesterday also we have seen it. The system is time invariant if its output signal does not depends on the absolute time. Now, what it means? So, in other words, we can say that if for some input x of t, the output signal is y1 of t. Now this tr is nothing but the transformation rule of the system. Okay. Now, therefore, y1t is equal to this tr into x of t. Now the time shift of the input signal creates the time shift on the output signal. Now there, if I shifted input signal with some time t0, so shifted input signal is how to represent it. So it is x of t minus t0. Okay. Now let us say the output of the shifted input signal is y2 of t. Then I will apply this transformation tr on this shifted signal x of t minus t0. So if you will get same shift in the output, then the system is time invariant. Okay. So if this is equal to, what is the output of original signal? That is y1t. Okay. If you get the same shift in the output of the original system, then this system is time invariant. Now, how to represent the same shift in output of the signal? So that is t minus t0 is there. Okay. This, no. So this is t minus t0. So you can say with this simple time shift in the same time shift in the input and output, you can say this system is time invariant. Okay. Now this time invariant system can be recognized from the fact that the transformation expression does not depends on the absolute time t, but t is only used at the as an argument of the input function. It should expression should does not depends on the absolute time t, but it can be the argument of the input function. It can be used as an argument of the input function. Now, in this case, let us take these three examples. So I have defined these three systems. System 1 with this expression, system 2 with this expression, and system 3 with this expression. Okay. Now let us take first example. Y of t is equal to t into x of t. Okay. Now in this case, how to find whether the system is linear, the time invariant or time variant. Now in this case, if I shift this input signal with some time minus t, and the input signal is shifted with time 1 by 2 and 1. So this is the original signal. This is the input signal shifted by half. This is the input signal shifted by 1. Okay. Now, if you apply this input signal on this system y of t, what you will get the output, how you will get output? So this output t into x of t, if you calculate, so what you will get output like this. For the first signal, it is this. For the second half shifted signal, this is like this. And for the shifted by one signal, this is like this. Okay. Now, by looking at the graph, can you tell whether there is a same shift in the output of the signal? Whatever time shift is in the input, is there the same time shift in the output? No, there is not same time shift in the output. Okay. So therefore, this system is basically a time variant system. If system is not time invariant, then this is time variant. Okay. Now let us take second example. Now in this case, the system expression is y of t is equal to xt square. Okay. Again, we have considered the input signal shifted by half and input signal shifted by 1. Now, if you find the output of this, what you will get? You will get the output as this. Now, these are the plot. By looking at the plot, you can say whether there is the same shift or not. But mathematically also we can calculate whether the system is time invariant or not. Okay, so that also we will see in the later in this tutorial. Okay, so you can see here, if you plot this system output, you will see same shift in the output of this system. Therefore, this system is time invariant. Okay. Now let us take third system. Y of t is equal to x of 2t. Now in this case, if you apply these inputs on the system, what you will get? This output. Now you just look at the output. There is a shift of half, half. Now here, can you see the same shift here? No, this shift, the shift is reduced, means minimized. But you can see the same pattern in the output. But this is not shifted by the same shift in the input. Therefore, again, we can say that this is time varying system. Okay, this is time varying system. Now, uh, we have analyzed these three properties, which is linearity, causality, and the time invariance. Okay. Now, how do these properties relate to each other? You can think about this, how these properties relates to each other. Basically, these properties are independent of each other, and this can be this can appear in any combination. Okay. Now, there are some examples. You can see these are some examples. Now, can you find out the uh, properties of this characteristics, linearity, causality, and time invariance for these examples? What about the first example? Can you tell me whether the system is linear or non-linear? First example is y of t is equal to xt square. This is non-linear system. By looking at the expression, you can directly say that using thumb rule, because this is square of input term. Okay, there is no scaling and additivity. So you can say this system is non-linear. What about the causality? Is this system is causal? Causal means what? The output should not depends upon the future input, but it can be depends upon the past and the present. In this case, if I want to find out y of 0, so I will need x of 0 ka information. Okay, so x of 0 is not the future input, it is the present input of the system. Therefore, the system is causal, right? What about the time invariance? Is this system is time invariant? In this graph also we have seen x of t is equal to xt square. This is the time invariant system. Now what about this y of t is equal to t into x of t? Is this system is linear or non-linear? Linear, correct. Scaling by t, right? What about the causality? Is this system is causal or non-causal? System is causal, correct. What about the time invariance? This is multiplied by t. So you can directly say that this is changing with respect to time t. Therefore, this is time varying system. Okay. What about the third system? Is this system is linear, causal or non-causal? Right, non-causal. What about the time variant or invariant? Then this final system example. By looking at the expression itself, you can see say that whether the system is linear or non-linear. This non-linear, correct. This is time variant system because this is depends upon sine of t. So sine of t is changing with respect to time only. Therefore, this is time varying system. Now let us take this example. Check whether the following system is linear, causal, and time variant or invariant. Okay. So the system expression is given like this. Y of n is equal to x square n plus 1 by x square n minus 1. Okay. Now to check the linearity of the system. So we basically check for the two cases. One is the time scaling We check for the two properties, time scaling and the additivity property. Correct. Now, let us consider for this system, I have given the input x1n and I will get output y1n. Okay. So for the input x1n, output is y1n. Now, how to represent y1n here? So y1n is equal to what is the system expression? This is the system expression. So y1n is equal to x1n square plus 1 by x1 square into n minus 1. Where is x? You can write x1 directly there. Okay. Now, let us say another input. I have applied another input x2 to the system and I will get output y2. So this y2n I can represent like this x2n x2 square n plus x2 square n minus 1. Okay. So instead of x, you have to write x2 here. Okay. Now, to check for the linearity, we need to find the weighted sum of the output. Now, what is this weighted sum of the output? Weighted sum means we need to apply some weighting factor here to this to output. This is sum of the output. Weighted means the first output is y1, second output is y2, and we have applied a1 and a2 are the weights to the output. Now, a1 y1n plus a2 y2n. Now, this is equal to what? The y1n we can write like this. Okay, already we have expressed our system in terms of y1n. Okay, so y1n is nothing but what? This x1 square n plus x1 square n minus 1. y2n is what? This is the y2n. Okay, addition of this two. Now, we need to find the output due to weighted sum of input. Here we have calculated the weighted sum of output. Now we need to find the weighted sum of input. Okay, output due to weighted sum of input. Now weighted sum of input means we need to put some weights to the input. That is, we are having input x1n and x2n. Okay, so a1 into x1n plus a2 into x2n. Let us say this is equal to x3n. And suppose I applied this input, weighted sum of input to the system. So I will get output y3n. Let us consider x3n will give output y3n. Now this y3n I can represent like this. Correct. Now this y3n is what? x3 square n plus x3 square n minus 1. Correct. Now, what is x3 basically? x3 we have already defined here, which is a1 into x1n and a2 into x2n. Okay, so you put value of x3 here. So this is a1 into x1n plus a2 into x2n ka square plus 1 by this square. So here we are having n minus 1. So instead of n, you need to write n minus 1 here. Okay. Now we need to check whether this system AY3N is equal to A1 Y1N plus A2 Y2N. What is this? This is the weighted sum of output. Okay. And what is this Y3? This is output of weighted sum of input. Okay. This Y3 is output of weighted sum of input, and this is the weighted sum of output only. Okay. If this is equal, then you can say that this system is linear. So here important property is scaling and additivity. Okay. Now by looking at this expression, let us say I will say that this is my expression 1 and this is my expression 2. Now if you look at this expression 1 and expression 2 here, are they same? By looking at these two expressions, you can say that these are not same. Okay, y3n is not equal to a1 into y1n plus a2 into y2n. Therefore, this system is non-linear. Okay, so like this, we can check for the linearity of the system. Now, how to check the causality of the system? Is it clear with you? Is there any doubt?
Yeah, doctor.
Okay. Now, how to check for the causality of the system? So I'm having this same system yn into is equal to this x square n plus 1 by x square n minus 1. Now, causality, causal means what? The output should not depends upon the future input. Now, in this case, if I want to find out the output y of 0, I will need information of x of 0 here and x of 0 minus 1, that is minus 1, right? I will need information of x of 0 and x of minus 1. Therefore, the output at t is equal to 0, this is not depends upon the future input. They are depends only on the past and present values. Okay, does not depend on the future value of the system. Therefore, future value of the input. Therefore, this system is causal. We can say the system is causal. Now, how to check for the time invariance? This is very important. Okay. Now I'm having this system. Now in this case, to check for the time invariance, first thing you need to do here is find the output. This I will say this is my step number 1. Find the output due to input delayed by k samples. This is discrete system, therefore delayed by some k sample. So if my output is delayed by some k sample, so how to write this expression here? So I will say that if my output is delayed by k sample, this is represent like this y of n comma k. Okay, this is representation of this. Now I can say that if my output is delayed by k sample, so I will write here x square n minus k plus 1 by x square n minus 1 minus k here. After this, you need to write n minus 1 minus k. This is what this is the output due to input delayed by the k sample. Now step number 2 here to find the output delayed by k sample. Here what we have we have found out the output due to input delayed by the k sample. Now in this case, you just need to find the output delayed by the k sample. So output delayed by the k sample is what? Y of n minus k. This is a representation when your output is delayed by the k sample. In this case only output is delayed. In this case, the input is delayed. Please remember this thing, okay? We are delaying in the input and finding the output. Here only the output is delayed by the key. So to find this, how to write this expression? X square n minus k plus x square n minus k minus 1. Okay. Now here first, instead of n, you need to write n minus k, and minus 1 will come later. That you need to remember. If you delete the input, you can say that k will come after this. Minus k come here. This will come here. Okay. Now, if you look at this two expression, suppose I say this is 3 and this is 4. The only change you will find here is what? This is same. But the only change, this is x square n minus 1 minus k. This is x square n minus k minus 1. But these two things are the same. Therefore, this expression 3 is equal to expression 4. This is equal. Therefore, the system is time invariant. Okay. If y of n minus k is equal to y of n comma k is equal to y of n minus k, then the system is time invariant. Okay. Is it clear with the time invariant thing?
Yeah, doctor.
Okay. So these two steps you need to follow here to find the time invariant. Now, can you do one exercise? I will give you one example to find these two properties. These properties. So let us take example. Suppose the system is expressed like this: y of n is equal to x of n plus 1 by x of n plus x square of n minus 2. Can you check these three properties? Linearity, causality, and time invariance. Okay, you take it as an exercise at home. Okay, homework. So please note down this example and take it as a homework. And we will